Hey, what's up guys? My name is Cherno and welcome back to my C++ series. So, today we're going to be talking all about function pointers in C++. And specifically, we're going to be talking about the kind of raw style function pointers that really come from C. So don't think that I'm kind of being misleading or anything like that. We are going to get into more the C++ way to do function pointers in a later video, along with things like lambdas, which are anonymous functions, kind of without a formal function definition, and all that stuff. We'll get into that as we go along, but first I want to start off with kind of the most primitive thing, which is kind of what I like to call a raw function pointer, which again comes from C. So what is a function pointer? So we've learned about pointers. If you guys haven't seen that video, it's linked up there. Make sure you understand what pointers are. You don't necessarily need to understand how memory works or how pointers work in C++ to kind of use function pointers, but you definitely do need to watch that video, so definitely check it out. But basically, function pointers are just a way to assign a function to a variable. So functions usually, as we've been using them now, if you don't know what a function is, by the way, I did make a video on that a while back, so definitely check that out as well. But the way that we've kind of been using functions so far has just been like as something that we call, right? It's not, we can't really like do any sort of logic with functions. It's just like a symbol that we can call when we want something to happen. And we can, of course, give it parameters and in turn receive something in return if we write a function that returns something other than void. So that's how we've been using functions so far. However, you can actually assign functions to variables. And like to extend from that, you can also pass functions into other functions as parameters. And there's a whole bunch of things that you can actually do with functions that really creates for some interesting and complex logic that would otherwise be extremely messy to do. It really cleans all of that stuff up. So the best way to demonstrate what a function pointer is and how to use it and what it can do is obviously by an example. So let's take a look. So the first thing I'm going to do is write a function, and this is going to be really simple. It's going to be a void function. It's going to be called hello world, and it's just going to print hello world. We're going to start off real simple here. Okay, so hello world, there we go. And then what I'm going to do is, of course, just call it normally, right? That's how functions work. We call it, this one doesn't have any parameters, so we don't need to put any parameters in. And if I run my program, of course, I'm going to get the text hello world printing, and you can see here that I do. Okay, great, perfect. Now let's assign this function to some kind of variable. Now we learned about the auto keyword, and the auto keyword is one of those things that is actually really, really useful with things like function pointers, and we'll definitely get into that in the future as well. But let's just give auto a shot and see if we can assign hello world to auto. So I'm going to create a variable called function, and I'm going to set it equal to hello world. Now, straight away you can see this isn't working because we can't deduce auto type because really hello world returns void. And what we're doing here is we're actually calling the function. But if we get rid of the parentheses, right, suddenly we're not actually calling the function, we're actually getting the function pointer. And specifically, this would look like this with an ampersand. So we're kind of getting the memory address of that function. Now functions are of course just CPU instructions, and they're stored somewhere in our binary when we actually compile our code. In the future, we might actually take a deep dive into the binary file and see our actual CPU instructions and how all of that works. But for now, just imagine that literally when you compile your code, every single function gets compiled into CPU instructions, and they are somewhere in our binary, in our executable file, right? So what we're doing over here with this ampersand is we're saying, hey, in this executable file, let's find this hello world function and let's get the memory address of those CPU instructions. That's basically what this is, right? So what we're doing is we're retrieving the location of the instructions to execute when this function gets called. And so now, we don't actually have to use this ampersand, by the way, because there is an implicit conversion, which we'll see in a minute. So you can just do this, right? Hello world, and that's it. So now what I can do is I can actually call my function like this, and let's actually call it twice. I'll hit F5, and you can see that I get hello world printing twice. So that's pretty cool. We've actually managed to assign our function to a variable. Now, this is auto, but what type is this actually? Well, if we hover our mouse over this, look at what we get. We get void, and then like an asterisk, and then function, and then some parentheses. Looks a bit weird. So let's actually write out that type. So we get void, then we need to give it some kind of name in our case because we are creating a variable. So before we called it function, let's call it function again. So in parentheses, I'm putting an asterisk followed by the name of my variable. and then any parameters that my function might take. So if it took an integer, I would put in int like that. If it took a string, I would put in string. Now we're not taking anything, as you can see. This is just no parameters here. So I can just kind of end it like that. This is the actual type. Now this does look weird because this is ultimately the type, kind of, right? It's just that we need to give it a name like any other variable, and function just happens to be the name. This can be Cherno, this can be anything you want. It's just the name. And then what we can kind of do here is just assign Cherno to, say, hello world or something like that. And you can see that it works like any other variable. And you can, of course, do that here as well. If I just write hello world, that also works like that. Okay, it does look very confusing. That's going to be step one. Like, I've called it Cherno, I'll call Cherno over here, like as if it was a function. If I hit F5, of course it still works. This does look confusing, I totally agree, which is why what people tend to do with function pointers like this is either use auto, or my kind of preferred way is actually to type def it or using it. So we're basically creating an alias for it. So what I mean by that is, instead of this kind of weird code, what we can actually do is say type def, then this actual type here, and we can call it like our, I don't know, hello world function or something like that, right? And of course, this hello world function name goes into here because that's our actual name. So it's basically the type, but we've put a type def at the front. What that now means is that if I want to actually use this, I can just type in hello world function, then a variable name like function equals hello world. And then of course I can just call function like that. Okay, let's make this a little bit more exciting. I'm going to add a parameter to here. It's going to be an integer. It's going to be called a. And then at the end of hello world, I'm actually going to print value and then a, just like that. Whoops, let's put this on the right side. All right, so now this hello world function, of course, we get an error here. We can't assign it because hello world is a function that takes in an integer. So what I'm going to do is change my function definition here to actually include an integer as a parameter. And now you can see this works. And when we call this function, which we're doing over here, we now need to specify an integer. So I'm going to type in 8 and then hit F5 to run my code. And you can see now I get the value 8 printing. So what I've kind of done now is I have a function that I can call using a variable name like this. And of course it's parameterized. So I can put anything I want into here and it will call that function with different values, which again is pretty cool. So that's the basics of how it works. That should probably show you enough to use it in pretty much all of its capacity. But now let's take a look at an actual useful example of why you might want to use function pointers in the first place. So suppose that I have a vector. I'm going to just include vector over here. I'll delete this code as well, and all of this in fact. I have a vector of integers. I'll call this values. I'm just going to assign it using this kind of initializer list here, like that, okay? And I want to create some kind of function which iterates through all of this and performs some kind of action. So, of course, a for each loop is basically what I'm writing here, but let's pretend that I wanted it to be in a function because maybe it did some other things as well, and that's just the example. So what I'm going to do is I'm going to write a for each function. I've called it for each. It's going to take in this standard vector of integers called values, and then it's going to do something. So I'll just say for int value in values, and then we want to actually do something. So let's go ahead and call this for each values. Now, how do we tell this function what we want it to actually do for each of these values? Well, the way we're going to do it is just by passing in a function, essentially. So up here, I'm going to create a function. I'm going to call this print value. It's going to take in a value, and all it's going to do is actually print it. So value, and then the value. Very simple function, right? And so what I'm going to do here is inside for each, I'm actually going to write one more parameter here that actually is this function. So it's going to be void. The name I'm going to call is func. And then of course it takes one parameter, which is an integer. So I'm going to write int like that. And then inside this for each loop, I'm actually just going to write func and then call it with value as the parameter, of course, because that's the current iteration of the for loop. And then inside this for each, I'm passing in the values, of course, which is our vector, and I'm also going to pass in this function, which is called print value. So now basically what we've got is a function into which we can pass in a vector of integers, and for each of these integers inside this vector, it's going to execute this function. That's what's happening over here, and you can see what that looks like. So if I hit F5, you can see what I get here. I get all of these integers that I've got, 1, 5, 4, 2, and 3, as I defined with my list here, and I'm getting this print value function executed with each of these integers as a parameter. So that's pretty cool. It's a way that we can kind of tell our function, hey, I want you to do this at a particular time. Now, this might seem a little bit overkill, so I'll show you one more way to kind of do this, and this will kind of lead into the next video that we have. So instead of kind of defining this function, it's a little bit messy to just have an extra function floating around, especially if we only intend for it to be used inside this for each function. So what we can do is use something called a lambda. And a lambda is essentially a normal function, except it's not declared as a normal function like this. It's kind of just declared during our code, and it's kind of a throwaway function that isn't actually a real function. It's an anonymous function. And the way that we can kind of declare that is by using square brackets like this, parentheses like this. We'll take in our actual parameter that we need to take in here, which is our value. And then with curly brackets, we basically tell it what we want it to do. So as if it was any other function. So we'll say print value, and then the actual value that we have, which is going to be value, which is the parameter that we passed in. Okay, just like that. Pretty simple stuff. Let's hit F5, and you can see that I get my values printing like before, but we don't have an extra function. We've literally just kind of written it in line. These square brackets are what's called a capture method, so that's how we pass variables in from the outside world. Our parameters go in here, and this is just like any other function body. We could even write it like this if you wanted to. And you can see that's the actual function. Okay, we're going to talk way more about lambdas in a video dedicated to lambdas. We're also going to talk about something called std function, which is standard function and standard bind and all of that stuff. So there's a lot more to actually discuss to do with function pointers. This is just kind of a gentle introduction so that you can see what they are and how we can use them and all of that. And also the primitive way of how they exist in C, which is just kind of like this void. And then it's just the signature is really, really weird, and almost no one uses this in actual C++ anymore, but definitely be aware of it because you will see a lot of code like that just in your programming life. Anyway, I hope you guys enjoyed this video. If you did, you can hit that like button. You can help support this series by going to patreon.com/thecherno. There are some really cool rewards that you'll get there for helping to support this series, such as getting videos early and like monthly kind of hangout sessions, which we do, and access to source code from all my other series and all of that kind of cool stuff. Thank you, huge thank you as always to all the Patreon supporters. This series would not be here without you, so thank you so much. I will see you guys next time. Goodbye. Ooh.